From the massive studios in Raleigh, North Carolina, this is the Cloudcast with Aaron Delp and Brian Gracely, presented by A Cloud Guru, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are. Welcome back to the Cloudcast. We are coming to you live from the massive studios here in Raleigh, North Carolina. You know, one of the things that Aaron and I set out to do this year was really to focus on some new topics. Not so much completely get out of the cloud, but really go focus on some new emerging areas that people have expressed a lot of interest in. We've seen, some new technology breakthroughs. And so today we're really excited about kind of talking about edge computing and what's going on around the edge, what's going on around kind of the evolution of what's happening as computing gets embedded into every device that we interact with, kind of all of the things that we do on a day-to-day basis in our lives. And for that, we really had to go out and find somebody who was going to think big about this. And we're excited to have an old friend of the show, but really excited to have Derek Collison on the show. Derek, welcome to the show.
Thank you, Brian. I really appreciate it. It's been a while since we've got to chat, but excited to talk with you.
Yeah. You and I have had a bunch of interesting conversations. You always, make me think, and I know you're thinking about the future. And when I saw that you were starting a new company, you were beginning a new company, and part of the focus was on edge computing, I thought, yep, I got to go get Derek. I got to go see where his thinking is on this, because you never get involved with things without really, kind of understanding the breadth of the ecosystem 3 or 4 years down the road, and then trying to figure out how to make an impact. So at a high level, I know, people probably know you, whether it's from your work, back at Google, at Tibco, you started the Cloud Foundry project back when you were at VMware, you started Apcera, but give us a sense of what's the new company that you're starting and kind of, it's really early days, but what's the big thinking that you're going after?
Yeah, I mean, it's really straightforward and simple, but then also making a bunch of bets on where we think the future is going. And the older I get, I think I feel I'm getting better at understanding where things are going, but I'm getting worse at how long it's going to take us to get there.
Yeah.
So at Tibco, I designed messaging systems that allowed computers to coordinate, right, and to work in large data centers and things like that. For Cloud Foundry, I didn't have a technology that really fit the bill to kind of do that from a distributed systems standpoint when we were building and architecting Cloud Foundry. And so I created a small technology called NATS, which is a very, very simple but very, very efficient, dependable, resilient, and always on type of dial tone technology that just does multiple messaging patterns, right? Pub, sub, request, reply, and queuing all in one. And so you don't have to, with HTTP, you've got request, reply, then you add load balancing in with routers, and you add all these different components. It just really simple, really works. And I built it for myself, meaning I didn't feel anyone would ever care to use it, and that was totally okay. And Cloud Foundry, I think, has been utilizing and benefiting from it for the majority of its existence, in different forms or fashion. And of course, Apcera was built on it as well. But what we found about 2 years ago, people started using it on their own, right? There's a disruption of the way computer systems would coordinate through the traditional enterprise messaging systems, right? And you see things like Kafka are filling that space of just disrupting it and changing the way we do that. But also the notion of platform technologies, which I've devoted the last 7 years or so, 8 years of my life to trying to make it such that things like decomposing monoliths into microservices is easier, right? We needed that technology to make 10 things as easy as one thing, right? And to get those advantages that we wanted. And so NATS kind of took on a life of its own. And so that combined with the topic for today's talk around edge computing, we really thought it was a great time to double down on the technology, create a company that really wanted to focus solely on the NATS ecosystem and bringing the notion of a digital dial tone to connect everything, right? Connect all the digital devices and services going forward. And so that's kind of where we are. And the big bet is on the fact that, we've got 7 billion plus people in the world. Depending on estimates, 4 to 5 are connected in some form or fashion, although the majority of those are at lower connectivity speeds. But at the same time, digital devices and systems and services will be north of 20 billion or so. Some say around 75 billion by 2022. Right. And so those numbers are a lot larger. And right now they all communicate through silos. They're all different the way they communicate. And we've seen the notion of value in connecting things on a consistent network, kind of like our phones that are in our pockets today. They just kind of work. I'm old enough to remember when they didn't just work. Half the time they didn't work, and
right.
You got off a plane in London and they definitely didn't work. There's no equivalent for that. And that plus the security aspect of really doubling down on making things safe and secure by default and still easy to use, I think is a need that the market really hasn't looked at deeply yet. So we're going to try to do that.
Yep. Excellent. Well, as I was thinking about, this, I was like, okay, we want to touch on some broad topics. The new company is still sort of new, so we won't dig into that technology too much. Obviously, like you said, NATS has been out there. There's been a lot of evolution of that, but I kind of want to talk about some of the broader trends, because I know you always are thinking about that the further down the road. The public cloud kind of grew, the usage of public cloud, it kind of grew in lockstep with what we saw in the growth of smartphones, right? So sort of the iPhone and AWS kind of timing wise was very similar. What are you seeing, or what are you sort of seeing as emerging trends that are driving this new interest that people have around edge or services around edge, right? Obviously it's more distributed than sort of the current public cloud. You've got, like you said, different bandwidth needs or different bandwidth availability in different parts of the world, geography-wise, city-wise, and so forth. What are some of those things near term and further term, that aren't so much smartphones that you think are going to drive this big change around the edge?
Yeah, I mean, that's a great question, and I think I've gone on record before where I really do believe edge will dwarf cloud computing, and I think there's a couple of fundamental reasons that are based in physics, right? Speed of light type problems. Mm-hmm. Historically, if you look back into, as far back as even the 50s and 60s, but I mean, 70s, 80s, 90s, we've, as an industry, have kept vacillating back and forth between, monolithic type computing and client server distributed computing in some form or fashion.
Right.
And we've gone back and forth several times, right? Now we feel that we're distributed, but if you think about it, we're still kind of in a client server model where the client is the browser and the server is a bunch of computers that are operating in a distributed fashion, but they're in a cloud somewhere.
Mm-hmm. Right.
And there's a lot of advantages to that. Now, that being said, you've got another technology outside of the proliferation of devices and communications that is also affecting these trends, which is machine learning and artificial intelligence. And, I've said this, but there's a lot smarter people than I have said it. But, our brains are about 50,000-year-old wetware. We can't really understand exponential growth effectively. We understand linear, and our primitive brains understand linear very well because, we need to know how fast we need to run to get away from something trying to do us harm.
Right.
Exponential growth, though, is what we're talking about with machine learning and AI. And if you've, at least from my perspective, been around in the late 80s, went through the first AI winter, what we're experiencing now, people really struggle to fathom where this is going to be in as little as 5 years and in 10 years. And there's a couple properties that are exemplified that are exacerbating the need for this notion of edge computing, which is, one, it's going to dominate, for the most part, our interaction with intelligent systems. Now, intelligent systems in the past were just software that, you and I would write or others would write. What's happening now is that, as you can see by, Google and Amazon and Facebook and Microsoft, Google especially leading, I think, is all of these crazy self-tuned algorithms and stuff that allowed Google search to dominate the world, and still does, are now being replaced by artificial intelligence. Now, what's interesting about that is that for the most part, when you're typing in, who is Brian Gracely? Google's really fast, right? But it is a speed of light problem, and they worked very hard to cover the globe of in and out, the door in about 200 milliseconds. when all of a sudden you change to start talking to something. And the cloud was the one that was doing the translation from, speech to text before it even interpreted it. All of a sudden, our brains started realizing, there's a little delay here, right? And we're starting to feel the experiences change in how we interact with these systems. And so what's starting to happen is that because the speed of light is what it is, we're trying to figure out ways to move these systems closer and closer to the end user. Now, what's interesting is everyone says, well, move it to the phone. And I do believe that those endpoint devices like that will play a massive role in edge computing. But I'm not necessarily thinking about that in the next 2 to 4 years, believe it or not. Yes, there's going to be a tremendous amount of innovation on endpoint devices like our smartphones and the assistants, right, like Alexa and Google Home and HomePod that are in our houses. But what I'm more thinking about is, okay, if you look at the way the trends with machine learning and AI are going, you can still use the cloud to train, massive amounts of data, training things. But once the model is actually kind of put together and things that can be modeled and won't change eventually very much, like understanding speech to text, those models can be proliferated all the way out to the edge, right? And so I think you're going to see this massive trend where two things are going to start happening, and they've already started happening, and I think everyone will keep denying them, but I promise you they're happening. I just don't know how fast they're going to happen.
Yep.
So most people feel that everything is still going to software and everything is still going to the cloud, right? I'm actually saying we're already in reverse on both of those trends, and that the things that we care most about interfacing with technology will move back into hardware. Customized ASICs that live on your phone, live in devices in your house, live on cellular endpoints that are the cell towers. And so when I talk about edge first, I talk about how do we initially start going out from a single cloud. And of course, then you go to multiple clouds. But then I think there's a massive wave where the telco verticals have a massive infrastructure that is the closest thing to you. In terms of the cell towers. And those cell towers are going to get more dense as we move to 5G, right? Because of the physics. We need more of them to actually cover the area. But speed of light is that the fastest response you can get from an infrastructure out type edge proliferation will be in the cellular networks, right? Yes, you can do it on the cable boxes as well. But I guess the point I'm trying to drive at is I think the first big wave that's going to affect us, even though we were staring at our HomePods and our Alexa devices and the new Samsung or iPhone, is going to be this massive transformation to gig LTE and 5G and the infrastructure changes to support it. Those endpoints are going to become more than just communication devices. They're going to become more intelligent devices. And so there's this notion of, I can actually have the most up-to-date, way to translate or get some sort of AI response that's actually the model is executing in the cell tower that I'm connected to. Right. One of the other things I think will happen, it'll probably take, again, longer than we think, Wi-Fi will go away. If you're in a urban city like San Francisco or New York or LA, you turn on your Wi-Fi thing and there's 50 of these things. I think 5G will get rid of all of that. Meaning that you won't need to use a Wi-Fi point. And so these models that are trained in clouds then will be boiled down to something that is deliverable as software, but it's a machine learning model that's being executed on customized hardware, and it'll continue to get closer and closer to us. I think you'll see this in the central offices within telcos, the 5G infrastructure, the cell towers, the base stations, the metros. Then, of course, you'll see the jump to inside the house, right? And you're already seeing it a little bit with, like, if you don't have great cell service, you can get like an extender or an amplifier or something put in your house that essentially makes it work kind of better. You'll see those start upticking and being more intelligent as well. The other big trend is that us processing information, there's things that are starting to come about where we need responses faster than the speed of light allows us to go to a cloud provider and back. So whether it's cars trying to figure out what they need to do, Right now, it's all self-contained, right? So your Tesla, downloads new software. It has all the new models that are the best it has so far. But eventually, they're going to start talking to other cars, and they're going to start talking to other systems. And they can't spend, 100 milliseconds going all the way to a cloud provider and coming back. And so you're going to see this proliferation of edge where not only are there communication endpoints further out from the cloud, things can work autonomously, right? You can actually ask someone that's very close to you to give you information that you need to be able to trust. So going back to NATs and this opportunity, the first thing I think needs to happen is secure and trusted communications that can proliferate all the way to the edges. So I don't have to trombone through a central endpoint that is Google or AT&T or whatever. I can talk to Brian, who's sitting right next to me because we're on a plane working on something, let's say, and his system knows something that I want to know.
Right.
I want to be able to trust it. I want to know that it's Brian's device and it's coupled to Brian as a carbon identity, and it's something about the data that I can trust, but without having to go all the way back. And so those three major trends, I think, are all kind of going to come together. The normal things within clouds that will translate out are platform technologies, right? How we can run lots of little things.
Yep.
And you're seeing massive amounts of innovation in that space. And so that's taking care of itself. It's still, got a ways to go. There's still a lot of ground to cover. But I think the all-in-one platform as a service ecosystems and then the infrastructure toolbox with things like Kubernetes and Docker and things are really kind of showing a path forward of how we can assemble and manage lots of moving pieces at scale.
Yep.
Once that's there, and you have the notion of being able to trust that, which was the whole reason Apsara existed, I think you'll start seeing things proliferate very quickly with the spread of the 5G kind of rollout, which is probably going to start around 2020 or so, but it might start earlier. Verizon's already doing testing and things like that.
Yeah. And I think you hit on a lot of things there. The first and foremost being it's not always that hard to predict the future. It is very hard to predict the time frame of the future to sort of get things right. But I think if you think about some of the things that you talked about, so the mention of things coming back to hardware. I mean, we're already seeing the beginning of that, right? Apple builds their own chips for iPhone, which is a massively popular device that's out there. So you have that hardware component. Amazon talks about their Alexa device, or whatever it's called, the Echo device, being the number one selling device they have. It has a piece of custom hardware in there to be able to do speech recognition and echo cancellation, all that stuff. We're seeing the price of solar panels come way down, which talks about the ability to manufacture hardware at much broader scale and so forth. So I think the building blocks are there for what you're talking about. And then, like you said, we're going to have systems that will become more proliferated that we want to get unique information from. And, you mentioned Tesla, like there's no reason in the future that, a Tesla can't speak to another electric car. Maybe it has to be a Tesla. Maybe it just has to be another, trusted electric car to understand, okay, the road ahead of us or the road that you traveled on may give me better insight about how an electric car should travel, for recharging or for, traction control or whatever that, might advantage, that type of thing. So I think you're absolutely right. We're at the beginning of seeing those things. I think people can start envisioning what those things might do. And then, like we've seen in the past, anytime you get cheaper chips and faster bandwidth brought to a different place into the network, all of a sudden you have this broad, proliferation of new stuff that happens and stuff that you can't necessarily always think about. So
I mean, now the only caveat there is that the bandwidth has served us extremely well, but where I think we are now with the edge is it's not a bandwidth problem. Yes, bandwidth will help, but it's a latency problem, right? And that's just a speed of light problem.
Sure.
So that's what I'm saying. So this whole wave over the last 30, 40 years of client server to, back to centralized, back to client server in some form or fashion, the reason I think edge will be so big is because I don't think we can go back once we get to edge. So you raised a great point with the iPhone X. It's got like 5 custom chips all doing different stuff. But if you could imagine staring at your phone, it looks at your face, uploads stuff, it analyzes it in the cloud, figures it out, and then let's say best case scenario, 3 seconds later it unlocks your phone, no one would use that.
Right.
No one would use it at all. And so Apple already knew that, and so they built, these models where they can update the models, and it's normal. It's not Tesla over the air, but I mean, you update your iPhone, and it'll get a little bit better model at detecting faces. It has to be local to the device.
Right.
Even Amazon now has really doubled down. I think they just announced that they're going to build their own custom, AI chips to, and data storage to put into these endpoint Alexa devices, because the use is getting so proliferated that people are starting to get very sensitive to the latency. How long does it take? And right now, everything on Alexa goes to the cloud and then comes back, essentially.
Yep.
And so they're like, we've got to move all of this into that device. And that's definitely one wave of edge computing on the consumer side that you're going to see proliferate. There's going to be no standards. There's going to be no cross-pollination of anything, which I think is sad. But at the same time, there's this other wave that people kind of don't look at as much, which is from the cloud out, right? Just slowly creeping closer and closer to you. And most of that land grab will be coming through the telco verticals and the infrastructure that they've spent, to be honest, hundreds of years, putting together.
Right. Now, speaking of that, I know, you're starting a company. You've done a number of startups. So as a CEO, you sort of have to think about the economics of the market you're getting into. Have you dug into kind of the broader economics of what the edge looks like? Obviously, it's always sort of this balance of, how much data can I afford to store close to a device? How much does latency cost or bandwidth cost versus, something else? What are you seeing kind of as the economics at the edge? Is it beginning to become advantageous? Are there some like big breakthroughs that are coming in a couple of years that you're going to say, okay, the cost of this is going to drop 90%, or have you kind of mentally gone through those models yet?
Yeah, I think the ability to move data, again, when you're not constrained by the speed of light, right? You'll never download all of the
Sure.
telemetry data from an airplane, right, over the air to a ground station. But the ones that you can, there's still going to be advances with bandwidth and latency around getting closer and closer to the speed of light. I think you're going to see huge amounts of innovation in custom hardware and the ability to do custom hardware that's extremely low power. I think, believe it or not, I do believe you're going to see trends to go back to software that's not as resource hungry. So even though I don't program in C anymore, I think it is going to make a little bit of a comeback, right? Because the energy usage on the endpoint is applicable. Where I think edge works well is that there is no flawed consumer bias right now. So what I mean by that is, and this is a big pet peeve of mine, that I'm going to try to help out and do what I think we can as an ecosystem and as a company to help fix. But the edge has the notion of a utility, right? And so you're going to pay for utilities. You pay for electricity, you pay for cable, you pay for your AT&T bill. Heck, you even pay for trash bags. But you can have software that costs tens of millions of dollars to develop, and you won't pay for it. It needs to be open source, and you're not going to pay for it. And that's right now is fundamentally flawed. And so when I look at the market, one of the things that I like about edge as a potential landscape and market to drive business into is that it already has that notion of, you got to pay for it. So you're paying for trash bags. They cost very little, but you still pay for them.
Right.
But you're not going to pay for WhatsApp, right? Or you're not going to pay for, Kubernetes, or you're not going to pay for, Docker. That needs to fix itself. And what I think might be interesting is that if there's a way, and I have thoughts on this that I've been working on for the last year or so, around how you can combine the best of open source and what it represents with business models that reward that open source ecosystem, I think is something that us as a community, and Brian, I know you're involved in this to some degree as well, as we all are, needs to be fixed.
Yeah.
Historically, if you've looked at anything that has met a market need where innovation is required to start, they all follow the same path early on. Whether it's closed source or not, there's a tremendous amount of financial incentive that flows back to the innovators, right?
Right.
There has to be. That's the way it works.
Right.
And then of course you get, pricing pressure and commoditization and democratization and open source alternatives. All that stuff makes sense towards the tail end once we feel that the market need has been saturated. Where we are right now as a community is that we are enforcing a consumer bias that it should be free. Everyone's default is, it's open source, should be free. Now, yes, there's models, and you guys are one of the best examples of where you can drive a very successful business around support and other types of things. But for a new startup coming on, if you open source your project or product, and you don't have a very concrete way of driving a business around it that is not just support based,
it's incredibly hard. Right.
Yeah, you're in for a really hard time.
Right.
And I think that's wrong. It shouldn't work that way. If no one cares about what you're developing and no one's using it, well, then markets do what they're supposed to do, and they prune that stuff out.
Right.
If someone's using your technology to do mission critical things all over the world, there should be an incentive flow for that technology. And it's a non-trivial problem, and it is one that right now is fighting upstream against a consumer bias that's being reinforced by large companies who are investing more in open source, who have revenue streams outside of that said project. So they don't need to make money off of it.
Right.
So they're reinforcing that.
Google and ads and things like that as an example. Right. Right.
Yeah. Yep. I mean, so what I like, and again, back to your question, although it was a long trip around the block, is that edge computing has this notion of, these things, even if they're services that are being delivered to the edge, are a utility. You might not have to pay a lot, but you have to pay for these things, right? And so, I'm looking at obviously hardware, bandwidth, latency, but I'm also looking at, proliferation of micro transactions that are very, very low cost. Blockchain is hyped probably beyond what it should be, but the notion of decentralized control is very, very important. If you're looking at a technology that you want to have global reach, you can't say, this one company will control everything. We know how the markets respond to that, right? It's not good.
Right.
I call it failure of your own success. And so this notion of things being decentralized by design early on, but you have to pay. You're paying into an ecosystem where lots of people can participate and, pay fees, but then also get rewarded and things like that. I think the answer lies somewhere around there. I'm sure I don't have all the answers. But I'm hoping that, a lot of the industry kind of looks at this and tries to figure out ways to fix this, because I do believe it's broke.
Yep. No, and I would agree. It's if there's not a way for innovation to be sort of at least have a reasonable chance of having, risk to reward adjustments that are fair in the marketplace, you're going to lose that incentive for innovation and so forth. So yeah, no, I completely agree with you. And I think, we've seen in the marketplace where sometimes, behaviors are hard to change in a certain area or a certain domain. But, like you said, in a new domain or a domain that has, more definitive kind of cultural norms, there is that possibility to go in and do those sort of things. Let me ask you.
You're exactly right.
Yeah. Let me ask you one last question. We'll keep this sort of short, but kind of wrap it up to some of the things we've talked about. So you've always been a big proponent of what like the Google Brain project's doing. You've talked a lot about kind of the advances in AI, and you hit on it a little bit when we got started. Do you see, AI having to be really different, or machine learning having to be really different for distributed edge systems, or are we going to be able to use a lot of what we've learned over the last, like you said, 10, 20, 30 years and 5 to 7 years, it's got accelerated recently, at the edge in the same way, or is there some sort of huge change that has to happen to make that useful? Right? It's the challenge of like, where do you have all the data? Where do you have the learnings? And then how do you apply the learnings?
Yeah, I mean, from my perspective, what I've been watching with, great, excitement, to be honest with you, is Google, and they did this very quietly, but they've become public with it, over the last year or so, is they immediately went into, we should probably think about separating out the training of a model versus the execution of a model. Mm-hmm. And so the training of the model, right, we went from CPUs, lots of CPUs, GPUs. Now, of course, there is hardware on the training side, but essentially we went to that model and then saying once we've trained the model, can we actually execute this in something that's more efficient, right? And this is where you're not even looking at FPGAs, you're looking at ASICs. And so when you look at like AlphaGo, it's amazing how fast AlphaGo can learn. Everyone sees that, they read the articles. Where I think people might miss out on, and it's harder to dig up, but the details around the first AlphaGo competition, how much hardware they had. So they had about a room size of special processing units that no one knew existed that were playing the game, right? Where it blows me away is that when they went back and they went up against Lee, it was substantially less, like an order of magnitude less.
Okay.
And now the last version where, it learned on its own and now it can go ahead and do everything, I believe, I could be wrong, but I believe it can effectively run the model on just 2 TPUs. So the amount of hardware needed to execute a super complex model that does something that no one's ever seen in the world is going down faster than Moore's Law was going up, in the 80s and the 90s. And that's where I think, it's like, wow. So think about that. So you can use all of the computers that Google or Microsoft or Amazon has to train these models. And there is still a lot of innovation, especially around the core models, right? Right now we have a plethora of them and we combine them to do different things. But I think the very low-level core algorithm, there's going to be a breakthrough in the next 1 to 5 years that is going to make everything we have today look like child's play. But even with the stuff that works, the fact that all of a sudden we can start executing these models in very small, low-power custom chips, and they can execute any model, like a TensorFlow model or whatever standard that we think will win out in the long run. That is huge, right? So we've got, we separated out training from execution. Execution is moving to hardware and moving to the edge. Training can still be in the cloud with lots of GPUs or TPUs or CPUs. That's where I think the big opportunity for edge is. So anytime you think about, interfacing with technology and AI plays a role, any innovation in that space is going to radically transform our experiences. And again, I can't even fathom where we'll be in 10 years, but I can promise you it'll be very similar to when you're on the highway and you can see a motorcycle in your rearview mirror and you look back up and it's blown by you. I mean, it's doing 180 miles an hour.
Yeah,
that's what's happening right now, and we're still looking in our rearview mirror going, oh, I can kind of see it. Yeah, I think it'll. We will blink and it is going to blow by us. So.
Interesting.
Fun times.
Yeah, excellent. Well, listen, with that, I'm going to kind of wrap it up. I know we covered a lot of topics, and folks may have to go back and listen to this one a couple of times to kind of dissect it all. But Derek, thank you so much for the insight today. We probably could do this for another hour, but thank you for it. Folks, real quick, Derek, if people might want to reach out to you, kind of, dig into, I know NATS has a really robust community today, but maybe pick your brain a little bit about, what you're doing with Synadia, or just kind of want to reach out to you. What might be a good way for people to do that?
Yeah, just shoot me an email, Derek, DEREK, at nats.io, NATS.io. And Brian, thank you for the invite. I always love our conversations and enjoy them. And I can promise the audience I'll probably get 50% of this stuff wrong, but it's fun to think this way and think, where the future is going for all of us. So I appreciate the opportunity.
Yeah, you bet. Folks, thank you so much. And Derek, thank you so much. Folks, with that, we're going to wrap it up. And for Aaron and Derek, we're going to talk to you next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more podcasts, show notes, and everything social media. And visit acloud.guru for all your cloud training needs.